Hello, everyone. Welcome to session 4. So during this session, we're going to discuss the circular economy and its role in developing sustainable food systems. So we have two speakers in this session. We have Luiza Toma, who's our first speaker and will be joining us online. Luiza is a researcher at Scotland's Rural College. Her interests include behavioural economic modelling and applying that to a range of systems, including the uptake of animal disease control technologies, food waste, and the circular economy. Luiza carried out a period of research with the Institute of Agricultural Economics of the Romanian Academy, and then has also worked with the World Bank, the European Commission, the FAO, and the OECD. After that, she went on to carry out a PhD at the Catholic University in Leuven, and she joined the SRUC in 2005. At the SRUC, she's been applying her economic modelling expertise to a range of different systems, so looking at animal health and welfare, food waste, and very relevant today, the circular economy, but also looking at environmental efficiency and also technological uptake of different systems. And she's been applying that in a range of projects, up to 30 research projects, so a lot of expertise in the area of the circular economy. She's also involved in teaching and supervision at SRUC and at the University of Edinburgh. So I'd like to thank Luiza for taking the time to speak to us today about a very interesting topic, delivering a circular economy in Scotland, a route map for making it happen. So thank you very much, Luiza, and I'll hand over to you now.
Thank you very much, Fionnuala, and thank you very much for inviting me to talk. It is a pleasure to be here, unfortunately, only online, but can be changed. So, we are talking today about a route map for making it happen, and it is circular economy, as Fionnuala introduced the talk. In terms of prerequisites for reaching a circular economy for Scotland, and I guess this could be something, a set of rules that may apply everywhere. I found that, well, probably because I'm talking as an economist, that data and measurement are really key. So harmonizing data sources and the way different institutions, different levels measure the data is very important. Otherwise, you will end up with anything but circular. Similarly, doing it in collaboration with all involved, so particular industry, however, also policy and research are very important here. And making sure that policies and legislation across sectors are also harmonized. And here I mean not only the policies and legislation focusing specifically on circular economy, but those maybe linked less directly, indirectly, or even apparently not at all. So having a nicely harmonized timetable for everything that ends up in legislation is important. And you'll see on the next slide why I'm making these 3 points. So I can't do that. Okay. So we have, I'm involved in a number of projects on circular economy with the Scottish Government and Zero Waste Scotland. And as part of one of these projects, we are trying to map circular economy for Scotland. So we are applying a systemic approach, and we look at how we would map food waste in Scotland. And what you see on screen is a very schematic representation of pretty much everything that follows on the next slides. So we look at food waste as the triangle from prevention to disposal, and look at factors influencing waste creation at different levels. Then what are the effects? And we are talking here effects on the environment, economic effects, and at society level. And what are the incentive mechanisms that any of the parties involved, government, banking, industries, NGOs, and research, could contribute to reduce the causes and implicitly the effects of food waste? We are discussing these relationships using something called a causal loop diagram. And this is, as I mentioned, an approach that is based on system dynamics. And what I'm presenting today is the first step of this analysis, which involves building, identifying the relationships between factors, effects, and potential incentives to close the loops. And the next step is basically assessing, feeding in the data and assessing quantitatively this mapping exercise. So in terms of factors influencing food waste at the different levels, we found this exercise involves a number of stakeholders. So we had Zero Waste Scotland, SIPA, and we tested also with a couple of non-academic stakeholders. And we found that the main factors that would influence mapping and food waste creation across Scotland involve data access and knowledge, technological development, infrastructure and logistics, domestic market competition, firm behavior, international market, we're talking trade, safety materials, and we're looking at that from the societal angle. Diet and health, again, societal perceptions. Cost and affordability, again, societal perceptions. And things that are outside anyone's control, or probably not so much if we manage to control a little bit more climate change, weather. So we decided to look, so there are different ways to map these, and that can involve sector-based or place-based. We are trying to put together both angles, and the idea is to first look at how waste travels through the supply chain. So we are looking first sector-based, and we bring in the place-based angle when you talk about interventions. So imagine that, well, you don't need to imagine, because I'm guessing everybody knows how waste flows through sector or supply chain, but the representation on this slide involves waste flows through the chain. So we talk about waste in tonnage from primary production, then following transport, distribution, primary and secondary processing, primary and secondary wholesale, primary and secondary retail, and hospitality and household consumption. The main areas where waste, I mean, in terms of magnitude and potential for intervention, identified for Scotland are agri-food, construction and demolition, textiles, packaging, electrics and batteries, and furniture. And in terms of how we structure the exercise, we consider that prevention, so the least scary bit is a waste triangle, is embedded through the effect of interventions on waste stocks and flows. We talk about waste tonnage, however, is a current step which involves feeding in data in the causal loop diagram. We are also attempting translation of waste from tonnage to greenhouse gases through the effect, as I mentioned on the previous slide, on environment. So in terms of how do we actually follow the quantification of waste between the different layers of the triangle, we have the reuse, we have the reuse element, which is an additional element of prevention, then recycling, and we talk about high value recycling, recycling low value, recovery, and disposal. And the different types of waste as the different levels involve redistributed surplus, surplus reuse, byproducts, then the next best thing, waste from agri-food sector, upcycled into biodegradable plastic, waste from agri-food sector, anaerobic digestion, waste from agri-food sector involving soil and composting. So We do this exercise for all the all the 6 sectors mentioned on the previous slide, and I'm guessing slides will be circulated. So for timekeeping purposes, I'll probably speed a little bit through this. But basically, we identified the different types of waste at the different layers of the food waste triangle. That includes agri-food, construction, packaging, furniture, and textiles. And from the best thing, surplus, byproducts, and redistributed surplus, we end up with disposal, which involves biodegradable waste mixed sent to landfill, sewer sent to landfill plastic, other non-biodegradable waste sent to landfill mixed, and waste, including persistent organic pollutants, incinerated without energy recovery. A part here that is also important, however, it is being dealt with legislation, and this for Scotland, is, and the rest of the UK, is how you deal with waste that is being exported. In terms of effects, we are talking about effects, environmental effects at economic and societal level. So again, here is when we can talk about translation of tonnage into greenhouse gases. And the environmental effects that we consider for this exercise include waste contaminated soil, impact on ecosystems and wildlife health, waste contaminated groundwater, and the link to greenhouse gas emissions through towards climate change and air pollution. In terms of economic effects, we identified green jobs creation, costs, including environment and health, reduced through waste prevention and mitigation, cost of waste mitigation technologies, cost of waste prevention and mitigation infrastructure, cost of new resource, energy, raw material. In terms of societal effects, we identified impact on household income and welfare, impact on health, impact on perceptions at societal level towards climate change, towards waste and circular economy. And in terms of intervention mechanism, we identified again a number of layers. Specifically for Scotland, this include local regional government, where policy is specifically focused on waste and circular economy. Then same focus on circular economy, but talking about islands and highlands policies. Central government, again, circular economy policy focused, and central government other policy, which is an important aspect because of the harmonizing bit I mentioned on the very first slide. Another important layer is, of course, industry incentive mechanisms and banking. I'm talking green banking here and NGOs. So there are different instruments and incentive mechanisms identified as different levels. And again, I'm going to speed a little bit through this. And probably just mention the ones we found a little bit more interesting and for which data is a little bit more available. We have, again, a local and also islands and highlands policy. One of the projects that I mentioned about focuses on islands and highlands, and media campaigns and education at local level was found to be quite important. More cost-related, so we talk about investment in redistribution, reuse, infrastructure and logistics, waste recycling infrastructure, investment in green skills, training opportunities. Again, that is an aspect that we consider in this project as well. R&D and innovation to support waste recycling technologies, which brings in research, such as a project that I was mentioning about, funded by the Scottish Government, R&D and innovation to support waste treatment technologies, monitoring the export of waste and circular economy strategies, more on that on the next slide. And the bit on harmonizing that links policies focused on circular economy at central and local levels, and the central government policies that focuses on other important areas, however, needing harmonization, and particularly in terms of timetable. So we talk about waste and circular economy legislation, for instance, data surveillance and sharing. However, these need to be coordinated with energy policies, health and safety, international trade, and climate change policies. That means that harmonization of legislation across policy sectors, climate, energy, particularly from the angle of data surveillance and sharing, are important. In terms of industry, mechanisms that are relevant were identified to be relevant as this layer are improved collective action to reduce waste along the chain. So we are talking collaboration across the supply chain, market-based incentives, particularly traceability, consumer research, redistribution. That is something that is done also in state-funded research. However, industry has quite a strong focus on this as well. Market-based incentives, price differentiations through labeling, development of waste, plastic treatment technologies, stick-type incentives, low waste standards required under processor retailer contracts, and development of byproducts and treatment technologies. In terms of banking, we focus less on these. However, we mentioned here green finance instruments as an umbrella. And in terms of NGOs, this is one of the main instruments identified is redistribution schemes. This, apologies for the small font here, but basically you saw the elements of this causal loop diagram. Linkages added on the next slide. It's simply putting everything you saw on the previous slides together. So we're talking about the different layers from the food waste triangle with the types of food waste, types of waste, including agri-food, identified at each of these levels, and then looking at environment, economic, societal effects, the bit in the middle, the blue, and then what you see down are pretty much the incentives mentioned on the previous slide. What you see at the left of the slide, so what you see waste prevention mitigation measures, here we identified a number of more specific measures, and we talk policy measures that were identifying the route map, so waste route map, and the circular economy strategy of the Scottish government. So we simply extracted a number of the measures included in these strategies, these strategy documents, that include single-use plastic ban, single-use disposable beverage cup charge, digital waste tracking, extended producer responsibility, and a number of others, some of them already in place, some other for which legislation is already in place, some others being planned for the next few years, short to medium term. This is just to give the context of the first layers, triangles, and the effects, incentives, and the very specific instruments brought from these strategy documents. When you actually add the links, so this is a smaller, more specific, more focused causal loop diagram. This is something that identifies the links between all the layers presented. So, for instance, you have one instrument, one incentives, and the effects of that incentives are identified on all the elements mentioned on the previous slides. What we do now is sorry. What we do now is feeding in data on in the loops created in the causal loop diagram for a couple of these incentive mechanisms. Again, we focus on policy, and data comes from a number of sources, and this is not the topic of this talk. I'm just I'm just mentioning what we do with a qualitative causal loop diagram and how we assess this in the current research stage. Something that was identified in a different project funded by Zero Waste Scotland is what would be the barriers and barriers to data sharing in the agri-food chain that may prevent the road, the mapping of a circular economy, and what are the interventions identified to deal with to deal with these causes for lower sharing, data sharing culture and environment in Scotland. So this presents the findings of a stakeholder workshop that had representatives from industry, from key institutions across Scotland, and we had policy and academia as well. So bringing together a number of stakeholders to discuss from their perspectives what are the factors that cause a lower data sharing culture and environment, and what would be the interventions, the main interventions that may lead to reduction in those causes. So interventions identified included targeting, prioritizing, and monitoring of data collection, mechanisms for ensuring consistency of data reporting, mechanisms for facilitating awareness of existing data, skills and capacity building, mechanisms for institutional harmonization of data needs, behavioral mechanisms for promoting data sharing culture, market mechanisms for promoting data sharing culture, which pretty much say that you cannot do this only when you target industry at a specific point within a sector or a specific node along the chain, the agri-food chain. So there was no stakeholder enthusiastic enough to identify one potential intervention that would target a very specific institution, a very specific type of stakeholder, a very specific node across the agri-food chain in isolation, which again brings us back to the prerequisites that I mentioned on the very first slide of this presentation, that collaboration is key and legislation is important. However, you can't actually have that unless you are aware how that will be received by industry in particular. The next slide presents these findings in a causal loop diagram format. And again, apologies for the small screen. However, those nodes are what I presented on the previous slide, and this simply shows the relationships between causes, effects, and interventions. This is an extraction of that causal diagram, talking about how one particular instrument, data sharing culture and environment, one particular instrument, mechanism for ensuring consistency of data reporting, would impact data sharing culture and environment, and what would be the impact on cost, and further on data gaps along the supply chain with socio-environmental outcomes. Next, the limitation to food system research, assumptions, and analysis. So pretty much linking legislation to further down cost research and mechanism, and linking all the way to behaviors. The current steps, we do circular mapping of materials by main Scottish economic sectors. The projects I was talking about focus not only on agri-food sectors, we also include other main sectors in Scotland. It's a longer project, started last year, and it's a 5-year project. We talk about feeding in data into the causal loops to rank the different policy interventions. So these are ranked by effectiveness, so the impact on the different layers mentioned: environment, economic, and societal. and assessment of the outcomes of combined interventions. So we try, but it's a combination of data backed exercise and simulation to account for any indirect and or unintended effects, whether synergistic or conflicting by those targeted by the policy. So again, the harmonization between policies focused specifically on circular economy and policies that are focused on others, such as trade or energy or climate change, but implicitly linked to circular economy. Acknowledgements, the views presented are my own and do not represent those of funders, expert advisors, or stakeholders contributing to the workshop. We are grateful to all. Thank you very much. How am I in terms of time?
You're good. Perfect. Thank you very much, Luiza. Yeah, thank you for your excellent presentation. It really does go to show that it's extremely complex when you look at trying to implement a circular economy and developing a route map with a lot of stakeholders, a lot of different drivers, and then measures that you need to implement to bring this about. So we have some time now for some questions from the audience, if we have any questions for Luiza. Okay, just as I give people some time to think about that, I might go ahead with a question of my own. Just in relation to food waste, Luiza. So if we're thinking about food waste and the waste hierarchy, so essentially what we should do is try to minimize the generation of food waste. But there are ways to valorize that food waste so it can become basically a resource for the bio-based economy. So for example, if we take anaerobic digestion, so we could be taking food waste, which we could technically avoid, so keep it in the food chain, but it can become a resource to generate biogas, which has an economic value, and then we also have policies supporting that. So how would you consider we'll say, different options for dealing with food waste within your route map for the circular economy?
Thank you for your question. I guess the technical details are definitely going to be presented by Owen in the next presentation. I'm just an economist. However, that complicated or at least busy diagram had input from quite a number of colleagues, including non-social science. As you remember, there are two layers that link from just under prevention. So we talk about recycling high value, recycling low value, and I'm guessing the link here, the effect on environment and particularly on cost, which is what I'm going to answer, is different as between the high value recycling and the low value recycling. So you would actually end up with less pollution for the high value because you do end up recycling more than you would from the low value one. However, in terms of cost, it's just the other way around because the investment in technologies to recycle is higher at the high value layers than the next one, and again disposal because of what you cannot do. And you didn't ask that, but because I just mentioned all the way to disposal, you would end up probably with an additional cost of disposal because you would invest in totally different types of technologies to deal with disposal of waste. So I'm not entirely sure. I guess I only answered part of your question, but the cost related
Yeah, exactly. Yeah, it's a complex picture, and the economics, I suppose, dictate an awful lot to do with it. Any questions from the audience? Great. Okay. Thank you very much, Luiza. Thank you very much for your presentation.
Thank you very much.
Okay. So we have our next presentation. We have Owen Fenton. Owen is a Principal Research Officer in Teagasc, working in the field of soil hydrology, soil water management, soil physics, and then also looking at bio-based fertilizer use characterization and fertilizer equivalency value within the bioeconomy. Owen has a H index of 41 and has published over 200 publications in the area. So he brings an excellent range of expertise here to us today. He's a member of the FACCE JPI Scientific Advisory Board from 2022 and an Irish Journal of Agriculture and Food Research editor. Owen is an honorary professor at NUI Galway, a visiting professor at the University of Sheffield, and a visiting scientist at CAU and CAAU, Beijing, China. Thank you very much, Owen. And Owen will be presenting today on recycling biological materials to agricultural land, the challenges and potential benefits to transforming sustainable food systems. So I'll hand over to you, Owen. Thank you.
Thanks, Fionnuala. Good morning, everyone. So the topic today really is bio-based fertilizers. That's what I call them, going to land, and some of the benefits, some of the research we've been doing, and maybe looking into the future, how we can improve our understanding of these highly heterogeneous materials. Okay, so we're all used to chemical fertilizers, which are 100% available to the plant. Okay, now if we start to look at maybe more bespoke fertilizer types, they are not 100% available to the plant, and therefore we need to know more about them. Okay, they could be lost like other fertilizers to the environment, and at the moment we don't know an awful lot about these, and there's lots of them. Okay, so we've been looking over the last 2 days about sustainable food systems. Adoption of sustainable farm practices will get us sustainable food systems, okay? One of these potential ways of doing that is using recycled materials, so recycling nutrients on farms, okay? And that is such a sustainable practice. Traditionally, we've been doing this, of course, for a long time, okay, with slurries, manures on farms. Okay, so we think this is a new area, but actually we've got a lot of expertise in this area already. So why are we doing this? If we look at this diagram, you don't need to know the detail here, you just need to look at the colors, okay? There's not a lot of greens on this diagram, okay? So what I'm getting at here is, why do we want to make new nutrients and keep adding them to the system, okay? We have nutrients that are available already that we can recycle and keep on recycling into the same system, okay? And there's two things to notice here. One is the European Green Deal, and the second is the circular economy, okay? So within the European Green Deal, we have lots of things that really point the way forward, okay? Both the farm to fork and biodiversity strategies want us to reduce nutrient losses by 50%. By 2030, okay? But they want us to do this while ensuring no deterioration in soil fertility. Soil fertility, to me, is matching crop demands, okay, to your inputs. If you can do that, you're not going to get a leaky system. You're not going to get nutrients being lost to water and to the air, okay? So soil fertility is, in fact, a huge practice that we can use to become sustainable. Now, all of this is in the context of reducing fertilizer inputs by 20%, okay? A circular economy is being promoted at Europe to try and allow us to achieve this. And there's several states already looking at recycled materials and really putting them into law, okay? And lots of these countries are showing the way forward. Okay, some more lovely pictures here of animals and different waste types. The first one there is animal manures. This is the one traditionally we know an awful lot about, okay? When you spread a manure onto a field, it's not doing the same thing as a chemical fertilizer granule, okay? So we need to find out how much is it doing the same thing or not the same thing as that granule. And there's many other waste streams available to us from the food and beverage or dairy processing industries. And today, I'm going to focus on the dairy processing one. Okay, I'm going to show you some research we've done within a European project called Reflow. Okay, so the dairy processing industry generates a huge amount of raw pea-rich material. Okay, and there's two types here. When you go out the back of the factory, there's a wastewater treatment plant there. Okay, so you get cheese made, etc. Out the back, there's huge vats of pea-rich material that could go to land, or indeed in the raw state. So that's what I call dairy processing sludge, this DPS. Okay, I'm going to abbreviate that in the next slides. So that's a raw product, a liquid product. But that can be processed further, either thermally or indeed chemically. And then that leads to other products, which aren't liquid really, they're powders, granule forms. And they're collectively known as struvius across Europe, okay? And they are ash, biochar, hydrochar, and struvite, okay? Now, it's expected that about 20 to 40% of mineral P fertilizers could be replaced by struvius products. Okay, so they have huge potential, and there's huge volumes of them being generated. What are the benefits that we know of besides their fertilizer capacity? All of these products have low metal contents. They have low disease spreading capacity. They eliminate greenhouse gas emissions because of the management of how they're managed, and they can use existing infrastructure to spread them onto land. Okay, so they have huge potential on our farms. So here's a little diagram. I'll take you through a little story of how this whole circular economy really works. So as I mentioned, you have your processing plant, out the back of which you have a wastewater treatment plant, and there's lots of things going on there. Okay, the liquid fraction can go directly onto our farms, and these could be dairy farms which are actually producing the milk and delivering it to that same factory. Okay, so there's a circular system going on here, and this happens actually right now in Ireland. So what could happen is, besides these liquid products, we could transform the liquid products into more granule forms, and they could be more easily adopted and sold as commercial fertilizer products. Okay, and at the moment we know a huge amount about the, I suppose, greenhouse gas emissions from these. We know about the microbial communities and their interaction, but we don't know an awful lot about their fertilizer equivalency, okay, or their fertilizer efficiency as fertilizers. So, what are the challenges when we get a product like a dairy processing sludge, okay? We need to test these products, and we need to, how long do we test these products? How do we test these products to find out if they're fertilizers? So what we have in Teagasc is we have a chain of facilities that can do all of this, okay? So in the Reflow project, we collected a huge amount of these products right throughout Europe. The raw products, but also these struvius products, and we tested them against that compound fertilizer granule. So what we do is we get them in, all of these products, and we characterize them, okay? We want to know their nutrient contents, their metal contents, and what we've done in this project is we've huge numbers of products now. We've developed a huge database of these products. Then we put them against crops. So we grow grass or wheat using these, and we have control experiments. They could be in glass houses or they could be in controlled environments. Controlled environments are inside. We can control the light, the humidity, and all sorts of things. And then out in the field, we have replicated field experiments where we can apply different rates, for example, different combinations of fertilizers, and see over about 1 to 2 years how these crops are doing in comparison to fertilizer granules. And then what we do is we publish on these different aspects, okay? So for a product to become a fertilizer, it needs to have that stamp of approval from many, many aspects, okay? Publication is the way to make a bio-based product or a waste into a fertilizer. You can't do it without getting that seal of approval. Okay, so the first thing we've done is, okay, it's all great having this data, but how do you make it work? How do you make it useful for other people? So what we've done in the Reflow project, first of all, is we've processed and characterized all these materials, and then we've looked at the metal contents. There are EU metal regulations for products going to soil, and we have our own agronomy or soil fertility tables out there. So what we've done is we've provided a calculator for any company or any product. You can put in your details, your characterization of that product, and then we can show you how much you're allowed to apply to land. So in essence, we have a nutrient management tool produced. It's adaptable to any country in Europe, okay? So we've done it for Ireland, and like our previous speaker, Jürgen, who I collaborate with from Denmark, we've created this for Denmark as well. So here I am back in my glass house or whatever. So we basically collect our materials, we apply them in pot experiments, okay? Very much like growing your plants at home on the windowsill, but here it's a more sophisticated version of that. We take our different dairy processing sludge types. For example, there's an aluminium form, a calcium form, or we take those strubious products and we add them to our crops, and we every so often come along and take our measurements from the crop, we take soil samples, and we compare them to mineral fertilizers, which we do the same, okay? So there's many cities of these plant experiments in Teagasc, where over about 1 or 2 years, we collect data and create growth curves. We still do that now with hydrochar and all the strubious products, okay? So here's the league table of results. I'll try to summarize it. To be or not to be a fertilizer. In other words, the assumption is that if you have a waste product, it's going to be a fertilizer, okay? And that is not the case, okay? There's a weed killer in here, and I'll point out which one I consider a weed killer and not a fertilizer. So when you look at the raw dairy processing sludge, the aluminium one had the best fertilizer efficiency, okay? So all the green here is good news, whereas the red areas are bad news as a fertilizer. So for example, the aluminium DPS here performed as good as mineral fertilizers, but in some cases, showing the heterogeneous nature of this, the efficiency was only about 22%, okay? So these materials are heterogeneous, okay? The calcium DPS had long-term potential, but not as good as that aluminium type. What about those thermal processing strubious products? The biochar, which you hear a huge amount about biochar worldwide, had a very poor fertilizer efficiency. So biochar created from raw dairy processing sludge, not good as a fertilizer, but maybe it has other uses like soil amendment to build carbon from a soil health perspective. Okay? So we're only looking at it here as a potential fertilizer. Then when we go on to chemical processing, struvite was absolutely the best fertilizer potential here, okay? So struvite, 3 of the 4 types were good as fertilizer, and again, right up there in terms of fertilizer efficiency when compared with that granule or compound granule. But the 4th struvite was absolutely useless as a fertilizer, okay? And the hydrochar had a low P fertilizer efficiency. So what I'm saying here is that all of these things have their advantages and disadvantages. But if you look at the ash was minus 151% of that, that chemical compound. In other words, ash killed everything that we put it near. Okay, that's a very, so therefore weed killer, as I was calling it earlier on. Okay, that's all lovely inside in the lab. Now let's take it out into the field. In Johnstown, we have this great facility where it's called the Cowlands experiment, where plots have been maintained at different fertility levels over 50 years. So some of these fields are kept purposely as P deficient or P balanced or in excess, saturated P. Okay? So this gives us a great opportunity to add these so-called fertilizers to these soils and see how they react. So what we found was very interesting. In the soil, you have different forms of phosphorus, okay? Some of which the plant can use, some of which the plant can't use because the phosphorus actually goes into lockdown. Basically, it locks itself away and it can never be released again, okay? A waste of money, in other words. Whereas other forms of phosphorus are very, very open for business. They can go either way. Okay? They can go into long-term storage, or they can provide the plant with the needs to grow the plant. We've developed an isotopic technique in Teagasc where you can look under the bonnet. Okay? This is a black box here, basically. Okay? So now, okay, where's the phosphorus going? Is it going into that long-term offshore account? Is it going into the plant? Is it going to be lost to the environment? Okay? And what we found was very, very interesting. When we looked at that in detail, all the products except hydrochar increased P availability for grass growth. But even at low doses, those struvite products decreased exchangeable P. So think about that. The exchangeable P is where we want the plant to take and to grow. And the struvite products, except struvite, stopped that from happening. So they became basically a guard or sealed off that potential use of P. When struvite and the raw material, but then they both increase that exchangeable P. So if you take the raw product or the struvite and add them to a grass crop, they actually are great in terms of unlocking P and making it available to the crop, even at low doses. Okay? So that's a huge advantage to the crop when they're being applied. And at low application rate, thermally treated products immobilized available P. Okay? Immobilized means it kept it in situ and made it locked down and not available for the environment, to be lost to water, for example. So again, this digging deeper, we came up with the same results as the previous growth experiments. When we looked at the first set, we had poor performance as P fertilizers, but when we looked at struvite and raw DPS, they are very, very good fertilizers and have huge potential to replace chemical fertilizers. Okay, so in conclusion, Strubius is soon to be good as fertilizers, and you know what? They're not all good as fertilizers, okay? Individual products need to be tested. So for all of these products we have in the circular economy from all the industries out there, we need to test them. Okay, we need to test them in detail. We need to know their profile. We need to know how they react to different soil types, different crops in the short term, but also long term. So if you conduct a short-term experiment, you may miss some of the characteristics of those nutrients further down the line. The thermal products may not be a sustainable choice as they have a low fertilizer efficiency. And here, the technologies and the feedstocks here need to be explored in more detail. Okay? The chemically treated DPS has the potential to replace mineral fertilizers. Okay? The raw products themselves, if they were left alone, they're actually pretty good. And the Strubius products are very, very good. These have high fertilizer efficiencies. But we need to adjust our practices to account for slower P turnover when we use these products and release. Okay? So they don't operate on the same timescales as mineral fertilizers. It takes longer for P to build up, and it takes longer actually for them to become exhausted as well in the soil. Now, going forward, I think what we should be doing is we should be looking at a broad range of products, and we should make sure we're implementing lab scale, field scale experiments over that two-year period. I get very worried when I see fertilizer products only being tested based on their characterization and not in conjunction with actual soil and actual crops. Okay? So thank you.
Thank you very much, Owen. Very interesting presentation, and again, highlighting there's so much complexity in the technical system as well. So we've time for some questions from the audience. Do we have any questions? We've got a question here at the front.
Just one question. You know, you just there when you were finishing up, you talked about a whole range. Now, you've been working on the Strubius project for a number of years, and, you know, to actually characterize from the recycling capacity of these dairy waste, dairy byproducts, sorry, won't use the word waste. And how, is there any shortcut to squeezing, so that when you get a range, somebody comes to you, I say, I've got a product here, can we have a look at it? Could you tell me quickly?
Yeah. It's the holy grail, right? What we're all looking for, I suppose, Owen. 2 years is a long time for a company to wait to see if their product is any good. What we're looking into is some analytical techniques, maybe in the wastewater treatment plants themselves, so high-resolution nutrient tracking, for example. That would give you an online and immediate answer how the spatial or temporal signal of the waste, fertilizer, let's call it, changes over time. the products inside a processing factory change a lot. Okay, so that means the product itself changes over time. There's a lot of analytical techniques that we need to start getting more into. The isotopic techniques are one, where you can do experiments over weeks and not over years. The only one where we're going to need time is the interaction with the plant long term. And then crops interact with soil and climatic conditions. So there will always be a place for field trials, but I think we could pre-screen, we could make the league table of 100 products down to 20, maybe down to 5, and put our money then in those top runners. And I think Struvite is one of those products that is a front runner at the moment.
Thank you.
Thank you very much. We've got another question. Okay, 2 questions here.
Thank you, Fatima Batista from MED. I was listening to your presentation, and I like it very much. Thank you, very, very interesting. And my question is more, in fact, Owen almost already mentioned this, because it's the issue is that everyone wants results for tomorrow. And the companies and everyone wants, and we are dealing with a system that does not allow us to do that. And my question was exactly, how do you think that we can deal with it? So you already mentioned. And also to tell you that we have some experiments also in MED, some researchers working with biochar and with other products. And yes, it's the same as you, very contradictory results.
Yeah.
Thank you for your presentation.
So managing expectations is a big part. Sometimes things are slower than expected. I would say about the biochar, it depends on the feedstock. So again, my results are dairy processing waste, biochar made from that, okay? So other wastes could be much better, but what you will end up is a huge league table of fertilizer efficiencies across all the waste types and all the processing types. So it's, I would encourage across Europe, we need to have a database of information. We've probably over 50 products in our database now, and we'll continue to add to that. So you can compare fertilizer efficiencies across. That data is quite a valuable resource to compare new products or older products as well. Yeah.
Here, Natalia, I work here in Teagasc and FarmBook as well. So just out of curiosity, are you doing any partnership with any dairy processors here in Ireland, trying to scale up?
So let's say there's been several projects. All the dairy processors in Ireland were involved in a project before Reflow as well. And there's a dairy platform in Ireland where dairy processors are very, very open to it's the raw products really now. There's another treatment now as well, which is biological. So I've looked at there thermally and chemically. There's a huge area of research now into biological pea removal at the waste sites. The big disadvantage at the moment is metals need to be added to the waste to trap the phosphorus for discharge licenses in the processing factories. And if you think about soil fertility, iron connects to phosphorus and it basically traps it in situ. Okay, so if iron is being dropped into the waste to make sure it doesn't get discharged from the factory, you now have a waste that's doing the exact opposite to what you want a fertilizer product to do out in the field. So if we can use biological processes to then negate the high cost of metal addition, that could be a huge leap forward. And there is some testing of that in Ireland with dairy processors at the moment.
Yeah, one question from my side, Gottlieb Basch from MED, University of Évora. Well, we all agree that circular economy is desirable, but as the word says, economy, did you look at any time into economic aspects or energy use footprint or whatever?
Yeah, so the short answer is yes. In a big project like these, a poor hydrologist like me won't be looking at them directly, but there will, there is other aspects of these projects. There'll be social parts, economics. I'm more on the environmental side. Like, as well, we've looked at, so in other words, yes, but I don't know the answer to your question directly, but it has been considered. Other aspects would be greenhouse gas emissions, carbon budgets, losses to water, for example, and yeah, so all of those aspects are in these big projects. Yeah.
Thanks. I might take one more question here.
Can I ask a poor hydrologist, or maybe a very smart hydrologist question? And it's a follow-on from Gottlieb's question there. The thing that came up in the conference over the last few days, or over the last 2 days, was the role of the consumer. And have you, or is that been looked at? Because we're putting away, if we go back 20 years here, now and even 30 years, this idea of putting sewage sludge out onto land was an issue. So I just wonder, have you...
Yeah, again, Owen, within those projects, the social science part would have been covered. But even to allow these products onto land, they have to, there's a very, very high threshold in terms of metal contents, in terms of carbon contents, and I think most of them won't make it to that threshold, in other words, very quickly. They wouldn't, some of these products will also have, smells, and but they're at least coming from, they're in the dairy processing side, they're coming from food waste rather than an animal waste, if you know what I mean. So I think maybe that if we call it that icky factor, maybe a lot less with these products than some of the products people are a bit worried about, like human waste, for example, going to land. Yeah.
Okay. One final question here.
Thanks, Owen. That's really good stuff. So just 2 quick questions, and maybe I missed this in the presentation, but can you clarify where the phosphorus is coming from? Is it from the milk, or is it from some other part of the processing system? And when you talk about the chemical treatment, is that in itself sustainable, or is it clean, or is it dirty?
Yeah. So the inherent P balance within the food processing plant, right? So that's where the P is coming from. It gets concentrated then in some of these processes at the back of the factory. Okay, so it gets concentrated, and then it goes out in that DPS waste. In terms of the chemically, it's not sustainable, in other words, right? From probably an economic cost, it's very expensive. So processors are spending a lot of money on additions of metals to trap phosphorus to meet their discharge license. Okay, that's why they're doing it. And I think the biological way would be, so let the bugs basically do that, and then without having to add the cost of a metal, which comes in a salt, for example, you would be dosing those wastewater treatment elements with metal salts to trap the phosphorus in situ. Yeah, so very costly.
Okay. Great, so we might leave it at that. So just like to thank our presenters again, Luiza, Toma and Owen Fenton. And thanks very much to the audience as well for your questions. Okay. Now I'd like to invite Owen Carton up to the stage to speak about a new research project, or a new project with Euragri.
Thank you, Fionnuala. You may have wondered why I was asking so many questions. I really wanted to avoid coming up here. I want to talk a little bit, just as we're kind of parking in a way the recycling or the circular economy, and we're coming back to Euragri. And this project is new to us, but it's also a new innovation for Euragri. You know, the way we've operated up to now, we've run conferences like this, we've run webinars, we've produced position papers, but we've never got involved in a project. And this is the first time, so it's an innovative project, and it's a networking project, which is what Euragri is about. But the first thing I want to say is, it's interesting, I feel part of the earlier discussion, because Mark 46 years ago, this week, I started my research career here in Ashtown. Right, 46 years ago. And you know what it was on? Crop fractionation, where we took the protein, squeezed the grass, took the protein out, and fed it to pigs. So, Mark, can I put that in my CV when I apply for a job? Thank you. So what I want to do is just give you some little bit of background to that this FarmBook project. Look down here. And what the project is about, who's involved, and the state of play. And you'll notice the very important thing is like the packet of cigarettes, there's a health warning attached to this presentation. And that is the presenter may not be able to answer all your questions. And the reason I'm saying this is that we're only recently involved. I also want to introduce there in the audience Mark. Mark Moore works with Teagasc, and he is also a member of this FarmBook consortium. So the first thing is, what's the question that EU FarmBook tried to answer? And I suppose it's one that we've all been thinking about for a while, because we're always interested in how quickly our research results get applied in the field. So it wanted to look at, can the outputs of EU-funded research and innovation projects be brought together in one user platform? So how do we bring that together? That was the question. And why was it asked? And it was asked because we want to improve how the messages from research and activities like that get transferred and used on the farm. And that's something that's of interest to everybody. And I suppose in some ways it's not a new thing. How do we speed up? This was the FarmBook is a particular approach to speeding it up. And speeding up the transfer and the application of knowledge on the ground is a key objective in the Horizon Europe programs. And so FarmBook, and we can look, at these funded projects by the EU over the years. Thematic networks were one. And there was over 50 projects funded, and there was over 100 million euro invested. Thematic networks were where people got together, groups of people got together, and they tried to look at their project outputs and then put them into a format that made those accessible to the end user, the farmer or the forester. Then there's a whole other group of projects, multi-actor projects out there. And again, this was a very good EU initiative where they brought farmers and scientists and advisors together to address particular problems. How can we fix this particular problem? And then they worked on it and they produced an output. And again, there's over €1 billion being invested in these projects. So there is a real interest in how we transfer that information to the farmer. And just to give you one example, Maeve Henshin, here, who spoke to us yesterday, might say a few words later on, was coordinator in this bovine project. So they've created this website, which is this, I think, the front page of, and that gives access to a whole range of fact sheets, videos, podcasts, and information that the farmer can use if he goes in and interrogates. And I think in listening to Mark and talking to Mark about it, there was a huge effort went into creating this, right? And there was, how do you put the right data and all of that together? So in a way, what the FarmBook project is about, in part is about, is providing a mechanism, right, to store that information. I think with these thematic networks, there's a requirement on the project coordinator to store that information for a minimum of 3 years. So just to go back, give you a little bit of history on the FarmBook project. The first project was Euragri, and that was started in 2019. And what that was about was people sat around the table and said, can we produce a blueprint on how we might put this platform together to hold this information and to make it available to farmers. And then they got a second project under the Horizon 2020 called Eureka, and what they did was build on that. So they went from looking at 29 thematic networks to including multi-actor projects. So they got a bigger, much bigger, broader collection of information. And they actually produced a kind of a functional demo version of how this FarmBook would work. And then we come to EU FarmBook, which is a 7-year project with 15 million euros worth of funding to kind of finish out that job and create that platform, that FarmBook platform that will supply information to the end user in a format that they want, a format that's easily accessible. So what will it do? This is the work. It'll collect information, knowledge objects. It took me a long time to figure out what a knowledge object was, but you probably all know. But a knowledge object is any output from a project, either a paper. Now, these tend to be practical, so they're not scientific papers. They're actually fact sheets or something like that that's easy understandable. So they want to collect those. They want to create, what's out there. And I suppose we should explain that Mark and our job, I representing Euragri, is to help and to be part of that information. We're called very grandiosely ambassadors in this project. And that's our job. It's networking, it's working with the people, bring them in, introducing them. So we're going to collect that information. And I'm not sure that we're going to have a lot of work to do there in that collection process. Big work going on in the background by the IT people is developing the platform itself, the technology behind it. And this is where we come in. We start to engage with the actors in it. That's our ambassador's role. And the next one is to communicate. Again, if we build and go to this expense of producing a big platform, right, we have to be able to get it out there. We have to market it, right? And I suppose to market it, it must work. But there's no use building a technology that's nobody's used. And then we have to look at, is the information getting out there and is it being used? Are we exploiting this product that we have produced? And a bit like Euragri, we're networks. So this Euragri is a network, this FarmBook network on a much grander scale. What it's committed to do, it's dissemination. Essentially, it's about disseminating information in a way that meets the demands of the customer, in this case, the farmers or the foresters or the advisors. And it's also, the second thing is exploitation. In other words, making sure that the information that's out there to do things better, to do things more sustainably, gets out there and is used on the ground. And I suppose in this process, this impact one, is where this is going to be used. And like in an Irish circumstance, I sometimes envisage, there was mentioned yesterday, one of the papers about the discussion group model that Teagasc uses. I would see this as a great tool maybe to get discussion groups going. When a bunch of farmers get together to actually talk about, we want to talk about grass growth this week. So they go in here, they could pull up a few little questions for themselves or, say, this is what this guy's saying. And then, you get the discussion going around. So it's a two-way traffic of knowledge. And so these are two groups involved, a contributor. These are people like Maeve who run the bovine project, right? And it's how do they disseminate their knowledge. So what the FarmBook is going to do, rather than Maeve having to set up a whole new platform to put out the bovine or the knowledge objects or to get the information out, this is what FarmBook is going to do. It's going to give her a platform so she doesn't have to develop the platform. It's also going to give her storage space for all the information in there. It's just going to pull it all together in one thing. So it's making it very easier and attractive for the project leaders and coordinators to put their information into this, because we're going to save them a lot of time and a lot of money with their knowledge objects. And then there's the other side of the equation, and that is being a user. And I suppose that, you know, what we're there is, this is what it's all about, is about getting the information to the user in a user-friendly way. There's a big consortium. There's 18 countries, as you can see there. There's 29 partners. There's 17 network organizations. And as I said, the duration of the project is 7 years. These are the 29 partners, and we have Teagasc down here, and we also have Euragri, and I think some of the delegates will see their own logos here. So, project implementation, we're in the early stages, and it's about implementation. So at the moment, Mark and myself are being trained are educated on how to be good ambassadors for the FarmBook project. They're also developing the technologies. Like at the moment, what we're learning is how do we get the knowledge object, and say we're using maize bovine as an technological network as an example. So how do we get maize knowledge outputs or fact sheets out and get them up onto the FarmBook platform? Then there's going to be continued building and engagement. That's building the platform. And then outreach and sustainability. Again, I see that's work for the ambassadors. That's building it up, you know, and making sure that it is used. And then there's going to be uptake and maintenance. And that is looking at the longer term to try and make the FarmBook project as self-sustaining as possible. And we're going to have the launch on the February the 8th of the first iteration of FarmBook. And this may be what the front page of it will look like. So thank you for your attention.
Thank you very much, Owen. I think that'll be a great platform, I have to say, bringing all the information together. Very useful for everyone.
Thank you, Fionn.
Thanks very much. So that brings to a close. Oh, we've one question here, if you're happy to take it. Pardon? Would you be happy to take a question? We have one question.
Only if they're easy.
Okay. Just here.
Well, thank you, Owen. It's me again, Fatima Batista from Med University of Évora. It's a very, very simple, and I think you will be very easily answer this. How can we contribute to this EU FarmBook? I think most of us, we have several materials, the KEO, knowledge objects, that you teach me yesterday. We produced several, and it will be a very good platform that to assure also for other projects to assure the exploitation of our results. But how can we be involved? Do you have already an idea of that? Thank you.
Well, the first thing is to say that Mark and I are just two ambassadors. There's ambassadors in each country, right? And their work will be to engage, right, with the research organizations or the EIPs, operational groups or other groups, but initially it'll be people doing the Horizon projects, right? So they will go out and they will say to them, okay, we'll be trying to work initially with the new project starting out, because, you know, we're coming in and we say, now we can help you deliver that project. And then there'll be another job of, you know, getting other projects that, like maize bovine one, up on the platform. Does that answer your question? Thank you.
Okay, thanks very much. I think there's no more questions, so we'll bring session 4 on circular economy for sustainable food systems to a close, and I'll hand over now to Professor Jerry Boyle, President of Euragri.
No, it's okay, Jerry, come up. This is just, I think we need to say goodbye to our Zoom participants. And listen, I hope that you got some good information out of the conference, and thank you for joining us.
All right. Good afternoon, everyone. And I don't want to keep you from your lunch, but I think it is important if we just try and summarize some of the key messages from this morning's session and yesterday's session also. So I'm going to ask the moderators really to do that job. So Uno, where's Uno? Uno, can you come up here, please? And of course, Fionnuala will be staying on. Unfortunately, Wayne Powell had to leave early, and come on up, Carl, yeah. But Maeve Henchin has graciously agreed to stand in for Wayne. Of course, we have Carl Walsh, who moderated the first session this morning. And I'm the outgoing president of Euragri, and this is my last official function, I guess. But I do think the proceedings of the last couple of days has really underlined the whole rationale for Euragri, and that's in this particular, the context of this theme, the theme of this conference has been to identify the lessons for how we perform research and innovation within the members of Euragri, which are predominantly research organizations that work in the public sphere. But I'm going to ask each of the moderators, I think they're in the best position to do what I'm going to ask them, which is to summarize really the messages for how we perform research and innovation from the various sessions that they moderated. So I'm going to maybe start with you, Uno, and then I'll go on to Maeve, Carl, and then Fionnuala. Uno.
Thank you. And those of you who remember yesterday know that it was the initial, you could say, accord of internationalization. That was the name of the game. And you also remember that it was the FAO starting. It was Dr. Jensen and then Fabio Cosso. Are you still here? There, yes. I know that you were still here. And it was together with him, other two representatives of the EU. It was Claire Berry and it was Karen Fabry in different functions in the EU system. So here we have the internationalization, and the Euragri is an international organization, but with, as the name says, European. I will stress this sort of general European, so we are not limited just to the EU, but EU is, of course, at the central motor, as we heard in the farm project just a few minutes ago. So what did they say? And then when I'm thinking about sort of the messages, I would like to combine that with sort of what we also heard later, because they did set the tone. And the tone, I would say, has to do with the themes. So the themes has been the sustainable food system. So systems stuff was up. I would say that it has also been very good, because the entry style of that session then also did set sort of a platform for what was coming after. So the system side has to do with what we now listened just a few minutes ago with the integration and the interaction of pieces. So that was up. I think the accord also started with a heavy move on the systems side. I think it was sort of implicit, but it's so really absolutely clear that there is this great challenge for society. So we are moving not in a sort of anything goes and now we have this. It is the great movement, and I think that all the four speakers had in various angles that tone also. And also, which was set as a framework for the further discussion in the conference as a whole, was the multiple scales. And it has moved from that initial meeting to coming back, especially in the end of yesterday. I think it was really interesting. Then, of course, we had this general food agri, because this is a food agri type of activity. So it was also in this first session a very strong remark of the importance of this. It's not a sector any longer. It's a focal point for super important discussion in general for where are our societies going. In that sense, I think it was also in the tone of this first accord, the ideas about contextualization. And the contextualization hangs on with regard to the knowledge structure in this system, be up to the discussions just an hour ago on sort of what is hanging together and what is not, and what is the possibilities. So I would say that the report says the starting session on internationalization with special attention to the EU sphere did set the style for all what happened later.
Okay, thank you. Maeve, what's your assessment?
Yeah, I think that you asked how do we perform research and innovation. I think looking at those two words separately and together is kind of important in terms of understanding the session that we were at. Because research, as you know, is the translation of money into knowledge, and innovation is the translation of knowledge into money. So I think our session was really about trying to understand for whom are we doing this, and for and by whom, I suppose, is that being undertaken. And it goes back to the contextuality point that Uno made there. And I think that the presentation was very much about trying to understand the practical perspective and the knowledge of and value of the practitioner, and I suppose redefining what we mean by experts in the context of doing research and innovation. It emphasised the importance of co-design and recognising the role and responsibility of all of us in co-designing and co-creating a sustainable food system. So again, it's not just the role of experts from a scientific perspective, but trying to understand how we can bring the other types of knowledge into the system and trying to work on the system together. Very much underlined the importance of culture and values, and also the importance of political leadership in this space as well. And obviously in terms of the strategy that we have in Ireland, Food Vision 2030, we try to position ourselves as leaders in sustainable food systems, but I think that's a challenging role, but nonetheless obviously a very important role. The session also highlighted, I suppose, the centrality of the livestock systems and the narrative that's around that, and the importance of trying to figure out how we can make the narrative more reflective of reality on the ground. So we had Thomas Duffy, who was talking about the farmer's perspective, and we had Brendan Dunford, who was talking about the farmer's perspective but from an ecosystem service perspective. And both of those gave us a very positive perspective in terms of what's happening on the ground and the positive changes that farmers are making with a little bit of support and help from the incentives that are available, from the education and advisory supports that are available, and ultimately, I would say, hopefully from the feedback from society and the market as well. And I was speaking briefly with Wayne about some of his reflections on the day, and he highlighted the importance of circularity as well, and he said that we really need to think about how we can harness the best science and leadership in that context, and that we need to have a framework for the deployment of technologies. And I suppose when we think about what we were talking about, I think earlier on today as well, the fragmentation of the science kind of in this space and the need to bring all of that together. But I think overall it was very positive, and I think it was very much coming out with the feeling that we need to let people know more about the good work that's been done, and the good work that's been done on the ground, translating science into practice. And we need to just work with farmers and food producers and processors to enable them to process and produce and process food in a way that will lead to a more sustainable food system. So
thanks, Maeve. Carol?
Yeah, well, just going down through it then, I think some of the key takeaways I took from our session, Elizabeth mentioned the point about environmental research being pursued maybe at the expense of some other areas, and I think that highlights the importance of this need for multidisciplinary and transdisciplinary research, and it's important that that was called out by Elizabeth. Another point that I think she made was around this need for feed, food, fuel, fibre. I would also add in ecosystem services, that is on our mind when we're conducting food systems research and ultimately maximising the value that we can extract from land-based resources. Another point I think that was coming through in a lot of the presentations was around that adaptation and resilience piece. That's becoming more important as we go through the next decade. I think it's going to become much more to the fore. We're very obsessed at the moment about probably mitigation, but as we go through to the 2030s, I think you're going to see that coming through a lot more, and we need to start planning for that better. Farmer involvement, and Maeve mentioned it as well, co-design. I think a lot of the speakers in my session had that up as an important component, and it really is. I mean, when you look at what Mark was presenting from the U-Protein project around the development of these new plant-based resources here in Ireland, it's going to require a very significant mind shift by the farming community to take on some of these new protein crops. So farmer involvement in the research is crucial. And then maybe two final points, I think. This issue came up a few times about compromises between solutions. Jürgen pointed to the issues that come up around cover crops and no-till in relation to nitrous oxide emissions, but we know that they have advantages in other areas, or in fact what Owen was talking about in relation to biochar. So that says to me that we need to be much more cognizant of these potential trade-offs when we're conducting food systems research, and be very well, at a minimum, be aware of these potential trade-offs and then try to find ways of addressing them or try to find synergies. And that probably brings it back to the ultimate point, which is that we need to build in more systems thinking and systems approaches in how we fund research and how we conduct research. And I think there was a good example of that in the U-Protein project that Mark pulled up, because that runs through everything from land use and sustainability of protein extraction and profiling right through to consumer perceptions of these products. Some of these areas are new for many of us, and I think that the point that Jürgen put up in his concluding slide around the need for new funding, new partnerships, new demonstration activities and living labs probably brings it all together quite nicely.
Thanks, Carol and Fionnuala.
That's all right. So we have just concluded our session there on the circular economy for sustainable food systems, but a lot of the themes that have been spoken about in the different sessions were also reflected in that particular session by our two speakers. The first speaker, Luiza Toma, focused on the route map for circularity, and that she highlighted three main things that need to be considered. So one is data access and knowledge. So I think that's really being reflected across the whole conference. Producing that data so we know what, we'll say, wastes or byproducts are available, what the characteristics of those wastes are very important when we're looking at ways that we can either try to avoid those wastes or try to find ways that we can extract additional value. So getting that knowledge out there is extremely important. Developing then the policy timeline or having knowledge of the policy timeline in the circular economy is very important as well. There are new policies developing in the areas of circular economy, bioeconomy, and trying to make those areas more circular and more sustainable. Then we'll have a lot of different policy and legislation in different sectors as well. So having an awareness of all of those contributing sectors into the circular economy is very complex. And also the role of then stakeholders in the circular economy is very complex too. And we saw with some of the diagrams that Luiza showed, the causal loop diagrams based on the system's dynamics, where a lot of different stakeholders are feeding in to the circular economy route map, really does show the complexities there. And I think that comes down, and it's been reflected in the other sessions as well, where we need to have multiple stakeholders and we need to take a systems approach in our research. So we're not carrying out research on one sector and developing new solutions for one sector that could have an unintended knock-on to another sector. We need to take a holistic approach where we're considering all of our relevant stakeholders together. And that's very difficult because even if we look at one sector and we're trying to develop circularity in that sector, you could have very many numbers of stakeholders. So working together, and we're using outputs from different projects, as Owen mentioned in the FarmBook project, that could be very useful. So we're not duplicating research efforts. She also then touched on the assessment of the impacts as well, so the environmental, economic and social aspects. And I think that was something that came up in the other speakers too. And Owen mentioned it as well when we're looking at the use of various different co-products or waste products as biofertilizers. We do need to be considering the impacts on the environment, but also the economic and social impacts too. And coming back to the data, I think that was a major theme of Owen's presentation. A lot of people might rush to say, okay, this biomass waste or this food waste is a suitable biofertilizer, but it really does show that you need to carry out the scientific research to characterize those wastes or byproducts to see what situations they're suitable in. So we're not developing processes where we're trying to use these biofertilizers that are not really having the effect that we would like to have. The timeline was mentioned, I suppose, as a barrier because we need to spend a lot of time to carry out our characterization and then run the field trials so we can get the verified information to allow the uptake of those biofertilizers. So I think, again, the sharing of data was a key point there, where we can share experiences from different research carried out in different countries so we can more quickly populate the database of potential biofertilizers. I think those are the main themes there. So when we're looking at developing the circular economy, really data is going to be extremely important as we develop it, hopefully in the most sustainable way for positive impacts on the environment, the economy, and then social impacts as well.
Thanks a lot, Fionnuala. Does any member of the audience here have a comment or an observation on the last 2 days? Yes, please, yes. Can we get a mic over here?
Hi. Just, I suppose, a common theme, I think, coming out through all the discussions is that everything is more difficult, more complex, needs more stakeholder engagement and more time and more effort. And I suppose the challenge to everyone is to do things quicker because the clock is ticking on the grand challenges. So just wondered, do you have any observations or thoughts around how we can get things moving quicker in the context of having to do a more difficult job that takes more collaboration? And I suppose in a world where we see increasingly that the main communication channels are more likely to generate misinformation than useful information. So just any observations on that?
Does anyone like to take that up? How do we, I guess, move collaboration at a faster pace? Does anyone want to, Maeve, do you want to?
I think a lot of the funding instruments are facilitating that. I think we know
Yeah.
we have the SFI centres, we have the multi-actor projects. I think a lot of them are trying to facilitate that. But I suppose the challenges, and we're starting to see it even in, excuse me, the current kind of calls that are there. You know, the people who are there available to lead those, they're being pulled into a whole heap of different centres, and you know we're probably trying to do too much too quickly, and we're still not joining the dots. I think we're just changing the scale of the challenges. You know, we're trying to address the problems in individual levels, in individual sectors. We're creating centres, and we're creating more silos there. So I think there's more work to be done to think about how we can integrate all of those, and it's an ongoing challenge, I think. But I do think we probably need to take some more risks, and you know that's something that is difficult, and particularly for a public sector organisation such as Teagasc. But I think we have to be enabled to take more risks, just generally as a scientific community too.
Okay. Carol, do you have a comment?
Yeah, I mean, one thing you'll see now from next year is the rollout of the new Sustainable Food Systems Partnership under Horizon Europe. So this is a new model under Horizon. It brings together a much broader range of actors beyond the research spheres, bringing in the private sector and farmers in a much more comprehensive way. Both ourselves and Teagasc will be putting funding towards that, but it's a new way of conducting research, and I think that might help to accelerate things, Paul. And the other thing maybe that we need to think about more is how we transmit what we know, which is quite advanced, to other parts of the world where it's not so advanced.
Yeah.
At the conference we had last week, the climate conference in the Aviva, we had Bob Rees from Scotland talking about the huge overuse of nitrogen fertilizers in some parts of Asia, particularly in China, and work that has taken place there to reduce that by half with no impact on output. And they're looking to us and Europe as leaders in this space. But we know an awful lot that we should be transmitting to parts of the world like that much quicker. And then we need to go on and just refine and elaborate our own systems in a more advanced way.
All right, if I could just make a quick comment on that, and I think maybe an opportunity for Euragri in the future. There's a multiplicity of institutional structures that support research in one way or another across Europe. And there are some very good practices that I think in all countries we could learn more about. Obviously, I'm more familiar with the Irish context. But for example, we have an industry development agency in Ireland called Enterprise Ireland. And they collaborate with research institutions and universities to promote research activity which is led by industry. That's one example. And it gives a very different texture, I think, to the nature of research that's conducted. Now, admittedly, a lot of that research is at the higher PRTL levels. But it's another dimension of a structure, or another type of structure, that can accelerate both the conduct of research, its relevance, and ultimately its adoption. But there are many other models, I'm sure, in Europe. The other one I think that's I'm very attracted to is the EIP model, which again is at a high level of TRL, but it does set out to embrace the research user, the farmer in particular. And again, there are a large number of really interesting examples how that allows co-design and greater effectiveness. But of course, we can continue to innovate, and we need to, around structures of funding research. Elizabeth, sorry.
Thanks, Jerry. And I think my comment probably feeds from that. The big fear that I have, which was my last slide, was around the pace of change needed and the pace of impact that's needed. And just following on from what you've said, I think what we need to start showing more so is the impact piece. So you've got a lovely example in Northern Ireland where we've started to improve the water quality of a certain catchment area due to the influence of research and good advice to the farmers in that area. The EIP projects exactly have had some great impacts and changed behaviours as well. So maybe showcasing the impact gives other farmers then the hope that it can happen, and maybe helps to start change that mindset and drive that pace as well. So I'm just on reflection. Actually, it'd be quite nice for this kind of a forum maybe to take that right through to the end point of impact as a feedback loop, even to then further encourage uptake going forward.
All right. Pablo, please.
Thank you very much. I'd like to build further on this last piece of a conversation about accelerating impacts of research results, innovation. As you know, I said yesterday I was involved quite a little bit of time into developing and moving forward innovation on the ground with European Innovation Partnerships. So I'm very pleased that there's some recognition in this room about this tool. But I would like to add another bit with this. The policy research interface. I think that Elizabeth herself has mentioned this in her interventions, and this, of course, of great interest for us, because in order to generate impact, us policymakers is also very much interested in understanding, extending our knowledge base, but in a way that then we can use it also to drive effective policies on the ground. So probably we may dedicate an entire further conference on discussing the challenges of policy research interface, but I'd like to know from the moderators or anyone else in the room about how we could move forward, what is missing, what are the interesting, effective examples that exist across Europe from which we can learn. And a wild idea is, what do you think about regulatory sandboxes for moving forward innovation in the agricultural domain? Would you think about any specific example where this could be applied, for example, within the common agricultural policy or any other?
Okay. Does anyone want to take that up? Carol Goodman.
Yeah, well, it's a very topical area. We're spending an increasing amount of time in this area, this policy science interface. We have some very good reports to work on. The one that was presented yesterday, I think it was by Karen. It was the group that Tom Arnold led. There's a lot of work, a lot of recommendations in that can be acted upon. But here in Ireland, actually, I think we do a pretty good job around science into policy and policy into science. It's partly a reflection of the fact it's a small country, and we have a very close connection between policymakers and scientists, helped in no small part by having Teagasc as an agency of the Ministry of Agriculture. It brings the science and the policy very closely together. From our perspective, we're now funding a new type of research, which are small, focused projects, research projects conducted to answer a specific policy question that arises in the ministry. So we only started rolling that out last year, and that's something that we want to build on further. But I think compared to maybe some other sectors, this sector is particularly good at science, at that science policy interface. Always room for improvement, but certainly here in Ireland, it's a very close connection.
All right. There's one, in fact, I had a discussion with someone over the last, yesterday about this issue, and they made an interesting point. When it comes to policy research, certainly within the university system, it's difficult to get credit for that work. Very often it doesn't lead to publishable outputs in refereed scientific journals, except maybe at the commencement stage, if we're building a model, for example, policy model. But then the analysis of different scenarios and so on, that is typically not published in scientific journals. And there is that disincentive there for particularly people in universities. It doesn't apply to the same extent within research institutions, but I think it's an issue. There's a question there at the back. Yeah.
Hi everyone,
Nicholas
Ryan, Golden Vale Research. So speaking to farmers that I know, and they're all very willing to get on board with new schemes, innovations for environmental impact as well, but a lot of them are growing way more frustrated about the extra red tape, the extra administration that they have to do as well. So I'd just like your opinions on how can we implement the best scientific research that goes into policy and then is executed on farm, without adding a burden to farmers that it's just getting worse and worse for them, because as we know, the average age of farmers is increasing year by year. There's a lack of young people coming in as well, so it's going to make it harder for them. And also, can we harness farmers better for research, for innovation as well? Thank you.
Okay. Fionnuala, do you have any comment on that? Maeve, maybe?
Yeah, in terms of, I suppose my main work is in sustainability systems, so I'm not entirely sure how we could come about that in terms of reducing the red tape. So Maeve might be more, I'd say.
Okay.
I can just throw my tuppence worth. I'm not, as a researcher, we're always trying to avoid bureaucracy with regard to funding agencies as well, so I can well understand where you're coming from. But I think there's a lot being done to try and use, remote sensing and artificial intelligence to reduce some of the burden. The AgNav platform that's been developed by Teagasc in collaboration with Board BIA and ICBF plans to develop work with farmers to show them their climate impact and their biodiversity impact, and work with them then to improve their advice and their credentials around that. But that's trying to pull in data that already exists without farmers having to fill in forms. So I think we have a very good examples in Ireland where we bring the data together from the different sources so that farmers don't have to manually input. So I think that's something that's going to be developed over time. And I had a colleague working with an EU-funded project called AgSnap, I think it was called, and what it was trying to do was to empower farmers to take pictures of biodiversity in their own farms and upload that to an app, so that makes it easier for the funding body to verify and accept the farmer's word for things. So I think there's a lot being done in that space. And with regards to your comment about involving farmers more, I think absolutely that's what we're all trying to do. But I suppose, again, it's sometimes you can have too much of a good thing. We have this, we're trying to engage the same farmers all the time. It's like involving small businesses. There's only so much time that people have to devote to attending focus groups and workshops and things like that. So I think that's just something we have to be careful of, and I suppose, work more in a more coordinated way, maybe with farming bodies to involve a diversity of farmers, maybe. And if I could just go back to the science policy bit, just an expression I heard recently was, we always talk about evidence-based policy making, but I've also heard of the expressions of policy-based evidence making. So just to throw in a kind of a cautionary note around that, I think sometimes we aspire to something and we kind of overcorrect, and I think we just have to be cautious with regards to that science policy interface, that we don't end up with that policy-led evidence making, if you know what I mean. So it's just that interaction needs to be managed to make sure it's positive always. Yeah.
In fairness, my experience of working with policymakers certainly opened my eyes that sometimes they have to take very difficult decisions very quickly with very low evidential base. And Carol, you would, I'm sure, agree with that. There's the reaction time and the available evidence, even if it is available, perhaps isn't tailored closely enough to the policy challenge. Look, I'm going to, unless there's one more question, I'm going to draw this discussion to a close. And just one thing I want to emphasize is that first of all, the slides will be available. Isn't that right, Owen? Yeah, the website. Yeah, there were some excellent slides, and I'm sure that'd be very useful. The other thing, just a few final comments before I ask Uno to say a few words. One thing even though I've retired now from Teagasc, I still work closely with farmers and dairy farmers in particular. And what came through today and yesterday was I thought there was a lot of positivity about the challenges we face. And that's not always the case, I find, within the farming community. I don't know, obviously I'm familiar with Ireland, but I suspect it's true across Europe. And when Jorgen was speaking earlier, I was really impressed by something he said that I believe really strongly in. Technology can offer an awful lot. It's not going to provide all the solutions. But if you're a student of economic history, you'll know that in the past there was a lot of pessimism about the capability of food production to match population growth challenges, and technology intervened. And I think that was a positive lesson that came through. For me, a number of lessons have been emphasized here in respect of how we conduct our research and innovation, particularly in the context of sustainable food systems. I think we've only commenced this issue by way of the discussion that's needed. Uno, I think we're going to have to revisit this topic quite a lot, because we're all learning, those of us that have and do work now, of course, in research institutions and universities, that in order to develop that system approach to how we do our research, we have an awful lot to learn. And hopefully Euragri will assist. So there's just a few points, I think, that have been mentioned already that came out to me very strongly as factors that will support the development of that system-based approach. One, of course, is what has been said here just now, is the importance of working closely with stakeholders. And I think that's not as easy as it might seem. We can sometimes, we can often pay lip service to that desire, to co-creation and co-innovation and so on. When you dig a little bit deeper, you find there still is that chasm between the researcher and the stakeholder. And I think that's the barrier that has to be broken down and will take time. There is a need for us all, particularly in research, to acquire a humility, indeed, that recognizes we don't have all of the answers, and that there is a lot to be learned from interacting with stakeholders. So to embrace that concept of both in science, which I think is a positive concept, I do think we need to work on our own values as to how we learn as researchers. And that's why I did mention the importance of EIPs. EIPs will only work if there is that trust between the scientist and the stakeholder, and it has to be a genuine trust. A second point, I think Elizabeth mentioned it, and I think there will be general consensus for it, is there is a skills gap when it comes to system research. I think the point was made in the training of PhDs, even at undergraduate and master's level. We need to build in that approach, because it is not the traditional approach of conducting research. Research tends to be more specialized, highly specialized. People work on individual projects, and the concept of working collaboratively on a program is a relatively new concept. And I don't think we worked out how we might actually implement that system in practice. Of course, collaboration is part of that. Where we don't have the skills, we do have to collaborate with, not in the first instance, with other colleagues in our own institutions, but also, more importantly, outside. And indeed, the point that was made today, particularly in the energy context, was a very good example of working with colleagues outside of our own agri-food sector. Again, the practicalities of doing that are difficult. You know, it's easy to say these things, but if you try to design a system that allows for that, it is not, it's not a trivial challenge. But I think it is potentially very rewarding. Elizabeth mentioned, and I think if we had more time, we'd have gone into it a bit further, she identified the need to develop platform sciences that embrace system approach and to integrate modeling approaches. I mean, the one thing you know as an economist, you think in systems, whether it be partial equilibrium or general equilibrium, that is a system approach. It's easy to do it in the model. It's much more difficult to have that approach embraced within an overall research program. I think Carol touched on another very important area, and indeed, I thought our colleague from Denmark, Jørgen Olsen, put his finger on it. There's a huge funding challenge for research and innovation to address the issues that have been around food systems. It's a massive challenge. Obviously, because it's a massive funding challenge, it's not going to be easy to address. And I often cite, Carol, you'll forgive me for this, but again, if we look in Northern Ireland, for example, just take one instance, the investment that's been made in soil testing compared to in the Republic or across Europe, then that's only one small dimension. There's 50 million or thereabouts sterling being invested on field testing of soils for the next 5 years. And that's only the tip of the iceberg in terms of the funding need. But probably more importantly, and Carol, you touched on that, is how we design funding. And I think we can use funding as an incentive to create the kind of collaboration, the multidisciplinarity and the interdisciplinarity that's needed. Funding will work. For example, take a very simple case, and I think, again, you instanced the U-Protein project. For example, in this organization, many years ago, or a number of years ago, we typically would conduct production research in isolation from processing research in isolation from consumer research. Now, that is anti-system for a start. What we need to do is design a program that allows all three dimensions to operate interactively. And I think that can be done through a funding mechanism. So I just want to conclude with a few thank yous. First of all, of course, I do want to acknowledge all of our excellent speakers, and I think you had some excellent speakers both online and here in your presence, and of course all of the moderators for the work they've done. Yeah, thank you. Well done, folks. Of course, I do want to thank all of you, particularly who have come from outside of Ireland, for your presence, both today and yesterday, and I wish you all a safe journey home. I do have to acknowledge my former institution here, Teagasc, for stepping in late in the day to organise this event in this splendid facility here, especially Frank O'Mara, and to all his colleagues, Paul Maher in particular, who is a member of the Euragri board as well, and everyone else, both the contribution of speakers from within Teagasc and all of those who supported this event. I do have to, of course, again, acknowledge the superb professionalism of Declan McArdle and all of his audio-visual team for, I've described Declan in the past, you'll know this, as the Teagasc Fellini, and he certainly is that. I mean, he puts on a fantastic show. All of the proceedings were live streamed up until this discussion here. So thanks, Declan, and all your colleagues there for that work. And finally, I would also like to thank, of course, Owen Carton, our new Secretary General, who's done a splendid job in putting together today's event. It largely fell onto his shoulders. And indeed for presenting us the resume of the FarmBook project. I now know what the FarmBook project is about, Owen, thanks to you. And it does seem quite innovative and well done. Again, I have to thank our sponsors for last night's dinner in particular, because if I don't, we mightn't get paid. So, I hope you all enjoyed yourself. Now I'm going to ask our new president, who's Owen Fenton from Sweden, from the Stockholm Resilient Institute in the University of Stockholm, to conclude the conference with a few comments.
Thank you very much. And I'm fully endorsing also from my new position what you said as thanks for all the participants, be the speakers, session chairs, the support staff, Owen's contributions as sort of mastermind of getting bits and pieces together. And it's also my role to give a deep thanks to Teagasc and having this wonderful facility provided for this European annual session. It has been great and wonderfully and smoothly done, and also, I would say, cheerfully in a wonderful way. With regard to persons, there is one person, and he's sitting here next to me. It's the now former president, Gary, and you should not only have applause and warm thanks for this type of session, these days here, the preparation of those things, but for years in the lead of this organization, we have seen the success of this meeting. So many thanks, and I think it's an open applaud is at the relevant both time and reason. So I suggest a big applaud to Gary. Rounding up there, I would say a one-liner. The one-liner has to do with what we have created together. I think this is a year we will remember. 2023 in Dublin was the time when we together identified for a widest possible Europe that the food agro dimension of sustainability is there as one of the absolute cores for handling the transition to a sustainable world. So it has both content, it also has the role of Europe. And as this is a European conference, I think that should be stated. Remember this when you are doing your own homework and writing the history. And we hope then that we manage to have a full speed together. Thank you.
Thank you. I should have said, of course, finally, I want to wish Una the very best as in the presidency of Euragri. Una.